Hello everyone. Hello everyone. Welcome back our class. Let's continue study chapter 6, thermodynamic relations. Section 3, Maxwell relations. From last several pages, we have learned ds equals 1 over t du and p over t dv from the first law. From the second law, we obtained dh equals t ds plus v dp. From the Helmholtz function, we obtained df equals minus s dt minus p dv. From the Gibbs function, we obtained dg equals minus s dt plus v dp. From these equations, we easily obtained the relations, Maxwell relations. Maxwell relations include 4 equations. Just partial t partial v s is constant equals minus partial p partial s v is constant is equation 18. Partial t partial p s is constant equals partial v partial s p is constant is equation 19. And partial s partial v t is constant equals partial p partial t v is constant is the equation 20. Partial s partial p t is constant equals partial v partial t p is constant is the equation 21. These equations certainly very difficult to remember, but from this picture we can find some law, some relation, circulation to remember these equations. For partial s partial v equals partial t, p partial t, partial s partial v t is constant, partial p partial t v is constant. We use this picture to circulation is easy. We help us to remember this equations. These equations is Maxwell relations. It's very important. The section 4, general relations of entropy. We know we have 3 parameters PVT. These 3 parameters is basic parameters. Also, we know only 2 parameters is independent. So we can use any 2 parameters to express another parameter. For example, to express the entropy S, firstly, we can use T and V to express entropy because TV as independent variable. So in this case, ds equals partial s partial t v is constant dt, and partial s partial v t is constant dv. From the mathematics, we easily obtain this equation just from the mathematics. And we know cv just is partial u partial t v is constant, is capacity, specific capacity. So it's easy to remember this equation just from the definition of the capacity. So partial s partial t v is constant can be changed as partial s partial t v is constant equals partial s partial u v is constant times partial u partial t v is constant. Because partial u partial t v is constant is cv, and partial s partial u v is constant just is 1 over t. So partial s partial t v is constant equals cv over t. Cv is a property, substance property is easy to test. T also easy to test. So we can use T and U and V, T and V to express the entropy change. Okay. Also, from the Maxwell equations 25, we obtained partial S, partial V, T is constant. Just as partial P, partial T, V is constant. You can find we can change into PVT the function. So we can finally obtained ds can be expressed as ds equals Cv over T dt plus partial P, partial T, V is constant, dV. Because partial P, partial T, V is constant, we think it is another coefficient of substance, kappa. We think it is the temperature coefficient of pressure. Its definition is kappa equals 1 over P times partial P, partial T, V is constant. Okay, we obtained the first ds equation. We obtained the first ds equation, equation 36. Here is the first ds equation. Okay, we can use T and P to express ds. In this case, we can do another differential for ds. ds equals partial S, partial T, P is constant, dt, and partial S, partial P, T is constant, dp. From the mathematics, we easy to do some differential for differential. We know Cp equals partial H, partial T, P is constant from the definition of the capacity, specific capacity we have learned. Therefore, partial S, partial T, P is constant equals partial S, partial H, P is constant times partial H, partial T, P is constant. Finally equals Cp over T. We think this equation is B. Okay, based on the equation 26, we have partial S, partial P, T is constant, equals minus partial V, partial T, P is constant. Transpolate to VTP, no S. Therefore, ds equals Cp over T dt minus partial V, partial T, P is constant, dp. Finally, continually equals Cp over T dt minus V alpha P dp. We can call it second ds equation. Alpha P is another coefficient of substance, thermal coefficient of substance. The third one expressed by P and V. Do the differential of P and V for S. We can do the differential for S by P and V. Obtain ds equals partial S, partial P, V is constant, dp. And partial S, partial V, P is constant, dv. Also, use the equation A and B to replace the some terms obtained. These two equations is very long. Replace partial S, partial P, V is constant. Partial S, partial V, P is constant. We can use the PVT, the parameters, to replace H, S, U. Finally, we obtained ds is equals Cv over T times partial T, partial P, V is constant, dp. And Cp over T, partial V, P is constant, dV. We can find this equation very long, very complex, but it's each term just TPV, no HUS, so can be tested. This equation is 38. That's the third DS equation using PV parameters to express, because PVT is easy to be measured. Okay, thank you.